Okay, brief synopsis of what we need in order to graph polynomial functions. Have the example, let's graph this function. It's in factored form. To graph it, first things we find are the intercepts. Find the x-intercept, automatically y equals 0. Now, if y equals 0, well, y equals this expression, so this expression would have to be 0. For what values of x is this expression 0? Well, first let's just write that down as an equation. Let y equals 0, write 0 equals product of these, x minus 4 times x plus 2 times x plus 6. Our solutions are the values of x that make this true. Now, the only way this is going to be so, the only way we can multiply three numbers and get 0 is if one of those numbers is 0. If none of them are 0, we're not going to get 0. The only way we can get 0 from multiplication is something's got to be 0. Something, one of our factors has to be 0. So we say, well, okay, this factor could be 0 if x equals 4, right? 4 minus 4 gives you 0. That makes the whole thing 0. Or if x equals -2, because -2 would make this factor 0. Or -6, because that's what would make this factor 0. So that the points for x equals 4 and y equals 0, x equals -2, y equals 0, x equals -6, y equals 0 are going to be on the graph. Well, here they are. Okay, now I've completed the graph. And you can look back at the M to E video where we did this in detail if you need to, but you've already seen it if you've done the homework. And these 3 points we call our zeros, our x-intercepts. Okay, so these 3 points have to be on the graph. Now, why the graph has a curve that looks like this? Well, we'll talk about that in a minute. Okay, anyhow, these 3 points have to be on the graph. Also, we can find the y-intercept. That's even easier. Because as soon as you see y-intercept, you think, well, where's the y-axis? Well, that's where x equals 0. Y-intercept occurs when x equals 0. You automatically think y-intercepts, okay, x equals 0. And we plug in 0 for all the x values. And we get -48. So that's very straightforward. We get y equals -48. So right there is the y-intercept. Okay, so that -6, 0, -2, 0, 4, 0 come out of this, our x-intercepts. And if we let y equals 0, we get x equals -48, so 0, -48. I'm sorry, to let x equals 0, get y equals -48. Get to point 0, -48. Then we got a curve that fits these points. Now, the curve can't go through the x-axis unless it's at one of these points. Why? Because if it goes through the x-axis, then y is 0 at that point. And if y is 0, then one of these has to be 0. And the only way one of these can be 0 is at these 3 points. Okay. If x is any number except this, this, or this is not 0, this is not 0, this is not 0, you don't get 0. You can't multiply 3 non-zero numbers to get 0. So the graph can only go through the x-axis at these points, or only touch the x-axis, turns out in some cases. Okay, well, that's okay. The question is, why does it go up like this? Why does it go down like this? And there's an easy enough explanation for that, although it takes a little bit of thinking. First of all, let's just expand this thing. Okay, we use a distributive law, we multiply all this stuff out, and we get x cubed plus 4x squared minus 20x minus 48. Okay? Now, if the absolute value of x is really big, meaning x is a big number on that side of 0, or a big number on this side of 0, then x cubed is so much bigger than x squared or x that it's just going to overwhelm these numbers. And if you just let X get big enough, X cubed will completely overwhelm everything else. And it's going to act like the X cubed graph. Well, what's the X cubed graph look like? Well, this is what the X cubed graph looks like. Well, everybody should be totally familiar with that. Okay, that's the X cubed graph. Now, that graph is going to be very similar to this graph for big absolute value of X. Now, I've got a little blue circle here near the origin. The absolute value of X is not large in here. So it doesn't apply. The graph doesn't look exactly like the graph of the X cubed function. Okay? It differs because in here, absolute value of X is not large, and the X squared term can easily be bigger than the X cubed term and all that stuff. And they can combine in a way that makes the thing wiggle like this. Okay? So X is not large, so P of X can wiggle in here. So what you have is the wiggles are what you see in this graph. This graph, we zoom way back so that the values of X are really big, and the wiggles are all but invisible in here, okay? But there are little wiggles in here, and if you zoom in enough, they look like this. All right? That's the way the thing behaves. Now, there are different ways that the thing can wiggle, but they can wiggle at most a couple of times if it's an X cubed graph, because it can only turn around so many times to go through the X-axis. If it's an X cubed function, you can have at most 3 of these. You have at most 3 zeros, so it can turn, after going through one, it can turn to go through the next. Then it has to turn back to go through the next one, and then it's done turning. So it can only wiggle that much. If you had 14 of these, it could wiggle up to 13 times, okay? And if you had 14 of them, it'd be like an X to the 14th, which is a whole lot like an X squared. It's an even power, and we should understand power functions well enough to understand that. Okay, so another example. If your function factors like this, okay? Find the intercepts. Well, I chose to find the y-intercept first because that's usually the easiest one. You just let X equal 0 and see what you get. So we let X equal 0 here, and we find that Y is negative 504. Now, as soon as you looked at that, you saw, well, that's obviously negative 504. Right? Well, no, it's not obvious. You got to figure it out, but it's easy to figure out. Okay? So we got negative 504 here for the y-intercept. What about x-intercepts? Well, x-intercept means y equals 0, so we write out this thing equal to 0, and we then find the solutions. You got 3 factors multiplied here that multiply out to 0. The only way you can get 0 is for one of the factors to be 0. It could be this factor, which could be 0, or it could be this factor, which could be 0, or it could be this factor, which could be 0. Well, setting each factor equal to 0 gives us an equation for each. And we can solve each equation. We get x equals 3, x equals negative 7, x equals negative 4. So we can put our x-intercepts. You know, I choose to draw vertical lines, dotted lines, and label them with x equals negative 4, x equals negative 7, x equals 3. Mark these points. And then we get a graph that wiggles a whole lot like the other one did, but with different values. Okay? Does that make sense? That's the process. So if you have this thing in factored form, it's very easy to sketch the graph. Okay? And of course, you understand that if we expanded this, if we did the distributive law, we'd end up with x cubed terms and x squared and x and constant terms. And it would act like x cubed at the ends because you have like an x here, an x here, and x here. It's going to give you an x cubed. Okay, it's going to give you a lot of other stuff. And you got to do the distributive law to find out what that other stuff is. But bottom line, it's going to have a 6x cubed out in front. Okay. Okay, well, there are other things that can happen here, but that's the process for graphing one of these things. And there are various ways it can all work out. Let's say, and I'm going to kind of check my arithmetic for my algebra, I guess, on one of the problems I did. Okay, let's say that we have p of x equals x cubed plus 4x squared minus 20x minus 48. Now, I'm going to claim so let's just do this. What's p of -2? Okay, it better be 0. If it isn't, I'm in trouble. Okay, p of -2 should be 0. That's -2 cubed plus 4 times -2 squared minus 20 times -2 minus 48. What's that equal? Well, if you cube -2, you get -8. If you square -2, you get 4, and 4 times 4 is 16. Doesn't seem to work. It's just, it doesn't seem to work just because I was ignorant it works. Okay. That equals 0. Now, don't ask me how I knew that. Although if you go back to my original example, you can see that it's actually right there. So I didn't do anything magical. Okay, so p of -2 is 0. It follows that x minus -2, which is x plus 2, is a factor of p of x. And it follows then that if you divide p of x by x plus 2, you shouldn't end up with a remainder. Well, this leads to long division. We do P of X divided by X plus 2. We're going to write that out like a long division. X plus 2. And then we have X cubed plus 4X squared minus 20X minus 48. So now we've got this set up. It looks like a long division. Now, you probably haven't seen long division since you were 10 years old. And it may be unfortunate, but hopefully it'll come back to you a little bit. And if not, just practice until it does. So the way we divide this, we divide X into X cubed. How many X's are there in X cubed? Well, this means that you find what you would multiply by X to get X cubed. Okay? What would you multiply by X to get X cubed? It would be X squared. So you do X squared, and you multiply that by X plus 2, and you write it down here. So you do X squared multiplied by X plus 2 gives you X cubed plus 2X squared. Now, if you remember anything about long division, you subtract this from this. So we subtract. Now, I'm going to use a little red minus sign here to indicate what I actually do. I'm going to do X cubed minus X cubed, which gives me 0. And I'm going to do 4X squared minus 2X squared, which gives me 2X squared. Now, I'm going to put something up here, so when I multiply it by X, I get 2X squared. What would that be? Somebody tell me what I would put up above so that when I multiply it by 2X, I get 2X squared. Well, it's got to be X. Okay. I multiply X by X, I get, I'm sorry. It'll be 2X. If I multiply 2X by X, I get 2X squared. So 2X multiplied by X gives me 2X squared. And 2X multiplied by 2 gives me 4X. Now I want to subtract this from this. So I want to subtract the 2X squared from the 2X squared, and I want to subtract the plus 4X from the negative 20X. So this gives me 0. And this gives me minus 24X. We'll write down my minus 48. X goes into negative 24. Then I don't really need the 0 there, so just kind of obliterate that. What do I put here? So I multiply it by X, I get negative 24X. And put a number here, so I multiply it by X, it matches this. Okay, so I'm going to put negative 24 here. And multiply negative 24 by X, it gives me negative 24X. Multiply negative 24 by 2, we get minus 48. And we're going to subtract this. But we're subtracting a negative, so actually means I'm gonna add the 24x to the 24x. I'm gonna add the 48 to the negative 48. And I'm gonna get no remainder. Okay. So x cubed plus 4x squared minus 20x minus 48 equals x plus 2 times x squared plus 2x minus 24. But of course, x squared plus 2x minus 24 could be written as x plus 6 times x minus 4. And this is just by factoring a simple trinomial. So now I've factored P of x. I've written P of x in this form so that we can sketch its graph. Okay. Do both boards. Okay. So what we've done P of x divided by then x plus 2 gives you this by long division. So P of x is x plus 2 times x squared plus 2x minus 24. And then by simple factoring, we get this. So the graph graph Q of X. So you guys find X intercepts, find the Y intercepts, and determine the long run behavior. Now, there's a lot of confusion here about what these intercepts are, and people are getting wrong conclusions. People are drawing wrong conclusions, okay? And this is because you're not triggering the steps in a way that shows you what they really mean. Okay, so first of all, x-intercept. You immediately write y equals 0. Okay. You don't start calculating things. You don't do what you think you ought to do. You do what follows logically. Okay, so you write y equals 0. Well, y equals x plus 2 times x plus 6 times x minus 4. So if y equals 0, what do you get? Now you see, I've written out explicitly what everything means rather than skipping to do what I think I need to do. Rather than skipping and doing something out of habit, I do it because that's what logic tells me I have to do. X-intercept, the logic is y is 0. Okay, that's what the x-intercept means. It occurs when y equals 0 because that's where the x-axis is. Then you write out what y equals. Y equals, yes. So if y equals 0, now what do you conclude? And what people are doing is they're putting zeros in for the x's and getting wrong stuff or something equivalent. Okay, if y equals 0, then 0 has to equal x plus 2 times x plus 6 times x minus 4. So what x values solve this? I'll just say what x values work. Have to be too formal with our terminology. We do have to be careful. What x values work? What x values work to give you 0? Instead of just reading the x values off, those that make x plus 2 equals 0, or x plus 6 equals 0, or x minus 4 equals 0. Solve these equations, you get x equals -2, or x equals -6, or x equals 4. Your x-intercepts occur at these 3 points. Now, what can you say about y-intercepts? Okay, well, it seems a pretty good progress here. You want to be sure to write down all the details. Okay? Because you get in a habit and you'll mix things up. You'll find y-intercepts when you're trying to find x-intercepts, and it all gets screwed up if you're not very clear. And if you write it out every time you do it, you'll become clear on what it is you're doing and why it is you're doing it. And then you're actually learning some mathematics, okay? Instead of just imitating a bunch of things that you don't understand. And the same thing is kind of true of long division. I'm tempted to tell you why long division works. And I might just do that, but let's finish this up. And the problem with long division is nobody remembers long division of real numbers, of numbers, okay? And don't even remember really having done it, something vague in the past. And the way mathematics is taught and learned so you can pass an SOL test rather than learn anything, doesn't lend itself to this kind of understanding, okay? Anyhow, okay. Y-intercept. What can you know about the y-intercept? X equals 0. Okay. Well, if x equals 0, then x equals 0, then y equals p of 0 equals. You could go with this form, but let's go with a factor form. You just plug in x equals 0. Okay, if you know x, the y-intercept, you're going to find a y value. Y is p of x, so p of 0 would be this, which is 2 times 6 times -4, which is -48. It's very easy to calculate it, but you're going to put yourself at risk of doing the wrong thing if you don't know why you calculated it and what it means. That's why you write it out carefully. Okay, so if x equals 0, you get this. So your y-intercept is at 0, -48. Now we can locate our zeros. We have x equals -6. And x equals -4. Oh, sorry. X equals -2. And x equals 4. Give us y equals 0. So we have these 3 points. When y equals, so when x equals 0, we get y equals negative 48, which is here. And then the expanded form has the leading term, and you have to read your book and listen to Open Math and check their videos and do what they say. Make sure you understand the terminology, but the leading term in this case is x cubed, because right there is your expanded form. Now, remember, we started here with the expanded form. We figured out just by trial and error that x equals -2 gave us a 0, so x plus 2 is a factor, so we could do the log division, complete the factorization, so we could write p of x in factored form. Okay, but before we had the factored form, we had the expanded form. The leading term was x cubed. But the long run is again like this. Meaning that over here, we're going to go down. Over here, we're going to go up. Now, Open Math explains that in a slightly different way. Talks about what happens if you use big numbers. People don't understand numbers. And I find that's of limited value. People do it by imitation, never really understand it. If you understand the graphs the way we've attempted to develop them in this course, then this fits very nicely and convinces you that this should be the right behavior, at least you can believe it without using too much sleep. Okay, so what we have is here are the wiggles. And remember that we're not doing this before. We said, okay, well, we can have wiggles in here, but this is when we're zoomed way back, looking at big values of x. Okay, it's going to look like the cubic function. Well, pretty quick we get to the big value of x, so the graph looks like this. All right, that's the essence of how you graph a polynomial. Now, it's a little more interesting. And let me just double check. So it's like, okay, we want to divide say x minus 5 into x cubed plus 3x squared minus 2x plus 4. Now, I don't think it's going to work. I don't think this is going to divide evenly, but I don't care. Okay, it's going to give us a result anyway. Okay, so x minus 5 multiplied by x squared equals x cubed minus 5x squared. Okay. Now, does that get us closer to x cubed plus 3x squared minus 2x plus 4? I'm gonna say, this doesn't give us x cubed plus 3x squared minus 2x plus 4, but it's progress. Okay. So if we write x squared here, then we can write our x cubed minus 5x squared. That's what we get here. And we subtract this. We subtract the whole thing. And we get 8x squared minus 2x plus 4. If we say that the multiple of x minus 5 that gives us this contains an x squared, okay, we know that, well, we've got a good chunk of it, but we still need this much left. So the way we write that out is we put our x squared here, we multiply it by x minus 5, and then we subtract it to see what we've got left, to see what we still need. Okay, so we've got this big of a chunk of this thing. We still need this chunk. Okay, well, we're going to get x squared plus 8x. Okay, so we're going to do x squared, we're going to add 8x here. When we add 8x, that's going to give us 8x times x minus 5. 8x times x minus 5 is 8x squared minus 40x. So we're like subtracting all this from here, which is going to leave us 42x plus 4. Well, to get 42x plus 4, Now we can add 42. So if we add 42 to what we're multiplying by x minus 5, we're going to get 42x minus 160. And if we subtract that, that leaves us with 164. Okay, well, we still need 164, but there's nothing we can multiply x minus 5 by to get us this. We can't get it, so it's a remainder. Now that's the logic. You might or might not understand that, but it might help you make sense of steps we use. Then, so x cubed plus 3x squared minus 20 minus 2x plus 4 equals x minus 5 times x squared plus 8x plus 42 plus 164. And we can write this as this, because of course we multiply through by x minus 5, multiply 164 over x minus 5 by x minus 5, we get that 164. Now, probably doesn't make a lot of sense to everybody, but we do need to teach the course in such a way that the people who can make sense of this, who can master the process in the first place and want to know why it works, and understand why it works, and also to at least give you the idea that there's a reason behind the process. Okay. We know that to build this up by multiplication, we're going to have to at least have an x squared times x minus 5, which will give us this, which leaves us this much. To get this, we're going to need an 8x. And 8x times your x minus 5, you know, right there it is, there's your 8x times your x minus 5, is going to give you this much, which will leave you this. In order to get at least a 42x, we're going to need a 42. And 42 times x minus 5 gives us this. We subtract this from this, we're left with 164 that we can't get otherwise. Okay. So there's a little bit to it. But not many students in a pre-calculus class are going to be equipped to understand that logic. If you can, it's worth understanding. And if you're going to be an engineer or something and you get a little bit of a late start, because we have had some very extraordinarily competent engineers come out of even our developmental classes, It's a disservice to them not to mention this. Okay. Because I find that my engineering students often have terrible deficiencies at the level of pre-calculus, even though they passed the calculus. Okay? Deficiencies just build throughout our educational system. And I think it's a crime not to attempt to address them. Okay. Well, that's the idea of long division. And that's the assignment, is to learn how to do long division. That's your assignment due tomorrow. After that, we can move into more analysis on how to graph polynomials and rational functions and make sense of all this stuff. I do advocate that everybody should really take a close look at what we've been doing in the support course for the last week, where we're talking about rational expressions. The algebra there gets pretty hairy, and people are doing pretty well with that in the support course. I think we really need to take a look at it because it's some of them harder algebra that we have to deal with. Okay. I have time for a couple of quick comments. If you have, let's say, if x equals x plus 3 times x plus 3 times x minus 4, if you remember what we just did, you'll find that at x equals 3, you have a 0. And at x equals, that would be x equals 4. Yeah, at x equals negative 3. You have a 0. And when x equals 0, you get what? 9 times negative 4 is negative 36. This has degree 3, so that the long run is still like this. So the long run is going to go up here and down here. Well, how are you going to draw that graph? If you start down here and come up through here, you can't get back here. Because you'd have to go through the x-axis and you don't have a point where you can. Because clearly the only x values will make this 0 are negative 3 and 4. So you got an idea, you offering a suggestion, I'll bet you have a good one. Okay, so we've got a good solution. Obviously, somebody's been doing the homework. All right, either that or just brilliant. You got both of those characteristics, okay? Yeah. It says, well, can you just touch the x-axis and not go through it? That's exactly what you do. You come up here like this. And then you come on down through here, and then you go merrily on your way up here. It looks just like the others, except it's down a little lower. It only touches at this point. And the reason that happens is you've got x plus 3 squared. Okay. Well, if you square x plus 3, you have a squaring function, you have a parabola, and there's your vertex at x equals negative 3. Okay. So this occurs as a result vertex of x plus 3 squared would be here. So this acts like a squaring function at this point. If you had three x plus 3's, it would act like a cubing function at that point. So that's important, and that's multiplicity of zeros that we didn't talk too much about today because we had to get the general procedure down. But you need to get that assignment done, make sure you have it, and if you didn't get it all done, make sure you work it, work it for practice, whatever.